Okay, so let's dive into something you've probably heard of, and maybe even dreaded a little, the root canal. But we're not going to talk about the procedure itself. Nope, we're going behind the scenes to look at the incredible microscopic technology that makes the whole thing safer and more successful than you could ever imagine. This is the hidden science that's totally changing the game in dentistry.
I mean, we've all been there, right? Lying back in that chair, staring at the ceiling, listening to all those little whirring sounds. But have you ever actually wondered what those tiny tools are? Because they're not just simple drills. Oh no, they are seriously sophisticated pieces of engineering designed to navigate a space that's almost impossibly complex.
The real hero of this story is this tiny, super flexible file. It's made from a special material called nickel titanium, or NiTi for short. The best way to think of it is like a microscopic, super strong explorer that has to map its way through these twisting, turning paths inside your tooth. Its whole job is to clean everything out, so that flexibility is absolutely essential, but that same flexibility creates a massive engineering headache. And that headache has a name: cyclic fatigue. It's literally the exact same thing that happens when you bend a paperclip back and forth, until it snaps. Every single rotation inside a curved root canal puts stress on that tiny file. Too much stress, and snap. And the absolute last place anyone wants a piece of equipment to break is, well, inside their tooth. So the billion-dollar question is, how do you make these things tougher?
Well, this brings us to a really cool competition happening right at the heart of dental science. To solve this whole fatigue problem, manufacturers use these special heat treatments to change the properties of the metal to make it way more resilient. And two main methods have come out on top, which we're going to call Team Blue and Team Gold.
So naturally, a group of researchers decided to put these two technologies head-to-head in the ultimate stress test. They took a bunch of the leading brands, some using the blue heat treatment, others using the gold one, to find out once and for all which one could take the most punishment before breaking.
And here's the lineup. In the blue corner, we've got files like R-Motion and TIA Premium Blue. And in the gold corner, we have Wave 1 Gold, TIA Vera Gold, and Y Plus Gold. Now, just looking at them, you'd probably think they're pretty much the same. But as we're about to find out, how they perform under pressure is, well, it's night and day.
So how in the world do you test something so small and so specialized in a way that's fair? Well, the researchers basically designed the toughest obstacle course you could imagine for these tiny instruments. It was a true gauntlet. And look, this isn't just some abstract scientific experiment. As the researchers themselves point out, understanding this stuff is essential for a safe and successful treatment. The stakes for the patient couldn't be higher, which is exactly why this kind of hardcore testing is so important.
The setup was incredibly precise. First, they made a steel block with a crazy curved artificial canal. We're talking a 60-degree curve to mimic a really difficult real-world case. Second, they put the whole thing in a 32 degrees Celsius water bath to simulate human body temperature. Third, they ran each file using its recommended settings. And finally, the simple part. They started a stopwatch to see exactly how many seconds it would take for each file to finally give up and break.
So they ran the test over and over. They crunched all the numbers. And when the results came in, it wasn't just clear, it was a total knockout. All right, so here's the big question. After all that punishment, being spun relentlessly in that super curved canal until they literally snapped, which tech was tougher, blue or gold? Wow, I mean, this chart says everything, doesn't it? It wasn't even a contest. The gold files, on average, lasted for about 298 seconds, so just under 5 minutes. The blue files? They lasted an average of 2,480 seconds. That is over 41 minutes. The difference is just absolutely massive. Let's just boil that down to one single powerful number. The files made with the blue heat treatment were over 8 times more resistant to breaking than the ones with the gold treatment. Not 10% better, not 50% better, 800% better. And when you look at the individual numbers for each specific file, the pattern is just impossible to ignore. The two blue files, R-Motion and TIA Premium Blue, both went for over 2,400 seconds. Meanwhile, the gold files all broke much earlier, around the 290-second mark. The data is just incredibly consistent. Okay, fine. So one tiny piece of metal lasts longer in a lab experiment? Why should you care? Well, because this is one of those times where lab performance has a direct, real-world impact on pretty much anyone who might need a root canal someday. Think about it. An 8-fold increase in durability. That's not just a small improvement. That is a gigantic leap forward in safety. It means the tool your dentist is using is vastly more reliable and way less likely to fail when it matters most.
So what's the real takeaway here? For us, the patient, it means safer procedures, especially in those really tricky, curved canals. For dentists, it means more confidence and more predictable results. And for everybody, it means a much, much lower risk of that dreaded complication, a tool breaking during treatment.
I mean, the study's own conclusion just puts it perfectly, loud and clear. When you're dealing with a difficult case, the blue-treated files are simply more reliable. That's the bottom line.
You know, this whole story, from the problem of metal fatigue to this intense battle between blue and gold technology, is just such a perfect window into medical innovation. It's stuff that's usually totally invisible to us as patients, but this relentless drive to test, to improve, and to perfect every single tool is what's making healthcare better and safer every single day. It really makes you think, doesn't it? If this much science and engineering and competition goes into one single tiny dental file, what other hidden breakthroughs are happening all around us, quietly making our world a fundamentally safer place? It's something to chew on. Thanks for watching.